All right, geometry, we are talking about triangles in chapter 4. So starting out, we want to be able to classify what kind of triangle it is. And so this chapter and going forward virtually, if you can't print off the notes, it's okay. You can still take the notes, but it's not going to be something where you have to write down every single thing on here or whatever. All I want you to make sure to do when you're taking your notes is to write down what I'm highlighting. Okay, so this first part is something you'll want to write down and draw a picture of. So we got basically four different ways to classify triangles using their angles. So if there's 3 acute angles in your triangle, so draw your triangle like that, that is based on the angles, that is an acute angle. Acute triangle, sorry. An acute triangle. And then if there's only one obtuse angle, all you have to have is one, we call that an obtuse triangle. Okay, pretty self-explanatory. And if there's one right angle, we call that a right triangle. And then finally, if there's 3 congruent angles in a triangle, that's called equiangular, like angles. That's an equiangular triangle, okay? And so equiangular goes right along with something else in this next part here, okay? So you don't have to write this down, but just kind of to run through that. CDE. So if I have CDE, that's that triangle. It has a right triangle. So that is a right triangle. Where BCE is like that. This is obviously here, the top right angle here for BCE is obtuse, so that would be an obtuse triangle, and so on. Okay, that's how you classify based on angles. Okay, so now if we base it on sides, these are some classification names that you might have heard before. Okay, so if you have a triangle with 3 congruent sides like this is called equilateral. An equilateral triangle is actually always the same as an equiangular triangle. They go hand in hand. And then this one, if there's 2 congruent sides, that's called isosceles. And that one's kind of hard to spell. Isosceles. And then the last one, if there's no congruent sides, none of these sides are the same length, they're all different, that's called scalene. That's a scalene triangle. Okay? So, again, in our picture, you don't have to write this down, but look at what we have. JKM. JKM is kind of the whole thing there. Well, none of those are the same, so that would be scalene. And then KLN. So KLN is this one right here. And it says that these 2 are the same, but the third one's different. So that's called isosceles. And then the last one, JKN, is this triangle here. It says all the sides are the same. So that is called equilateral. Equilateral. All right, so we want to be able to classify based on both angles and sides. Okay, so based on these pictures, let's just do the 9, 11, and 13. We'll just do the odds here. So in this case, first of all, it's a right angle. So look at the angles first and the sides second. Okay, so the angles, it's a right angle. So it's a right, and then it's also 2 of the sides are equal, so that is also isosceles. Okay, right isosceles. Okay, so look at number 11, same deal. It's got, for angles, they're all the same. So that is an equiangular and all the sides are the same, which is going to happen. When you have equiangular, you automatically have equilateral. Okay. And then finally, look at the number 13. Once again, we have a right, but this time, none of these sides say they're equal. So we have to assume they're all different. So that would be scalene. Okay. So keeping that in mind, we have some examples here where we're using our algebra. So it says something like this. Number 1, ABC is an equilateral triangle. Solve for x and y. So if it's equilateral, that means all these are the same. All these are equal. Well, I can't say something like, like this equals this equals this. Okay, the equal sign would just be for two at a time. So I'm just going to choose 2 of them. So I'm going to go 3x plus 1 equals 49. Equilateral means the triangle's sides are all the same. So I subtract 1, get 3x equals 48. And when I divide by 3, I get x equals 16. Well, again, if that's 49, now I'm going to go these two. So 18y minus 41 equals 49. Now I got to solve for y here. So I've got 18y equals, and it looks like that's going to be 50. So 90, yeah. So 90, and then divide by 18, and this one I get y equals 5. Okay? So, and that's how we kind of use what the information tells us in that case. All right, so in this case, we're kind of doing the same thing, and then we'll move on. So they all are trying to find x. Well, again, I can't set them all equal to each other. I just got to pick 2. So 12x minus 22 equals 10x minus 6. So I need to get x on the same side. Get 2x minus 22 equals negative 6. I'm going to add 22 to both sides and get 2x equals, what is that? 22 minus 6 would be 16. So divide by 2, x equals 8. Okay, but look at what the directions say and the measure of each side. So, well, they're all the same, so all I have to do here is plug 8 into one of those sides. So I'm just going to plug it into ST, and I get 10x, 10 times 8 minus 6, so 80 minus 6 is 74. So ST equals 74, SR equals 74, and RT equals 74. And there we are. Okay, so that's kind of how you can use the algebra to solve for missing parts. Okay, and so on our 4.2, we're talking about the angles of any triangle. So any triangle is going to be this first one. So this is also very, very important that we write this one down. Okay, I'm going to go back and see if there's anything else we need to write down for the first part here. Yeah, so basically these two parts are the most important parts, making sure we're writing down these full boxes. But other than that, they're just examples after that you can write down to help yourself out. Okay. And so on this one, triangle sum theorem and exterior angle theorem. Okay. So this first one says the sum of the measure of the angles of a triangle is 180. So when you look at a triangle, there's always going to be 3 angles, right? So measure of angle A plus measure of angle B plus measure of angle C always equals 180. So any triangle, no matter what, the angles inside of a triangle always add up to 180 no matter what. Okay? And then the second one, it says an exterior angle is formed by extending one of the sides of a triangle. So angle 1 is created by just being on the outside of one of the triangle's sides. So when you're looking at this triangle here, you just extend one out, and that's an exterior angle. Okay. So if there is an exterior angle, you know the measure of that is going to be the two other angles. Okay, so angle 1's here. The two other angles that aren't attached to 1 are 2 and 3. So if that's the case, the exterior angle theorem says measure of angle 1 equals the sum of those two. Okay, so an exterior angle is always equal to the sum of the two non-adjacent interior angles. Okay, so let's kind of use those two things to solve some missing parts. And again, I'm not going to highlight these, but these would be helpful to write down. So find all the missing angles. So I've got 24, I've got 37, and I know the rest is going to be whatever is in 180. So angle 1 plus 24 plus 37 equals 180. And so that's 24 plus 37 is going to be 50, 61. And then subtract 61. So really it's whatever's left over in 180. So angle 1 equals 119. Okay. And then number 2 is using that exterior angle theorem. So angle 1 in this case equals the sum of 76 plus 52. So angle 1 is, that's 128. 128. There we are. Okay, so it's just a matter of using those missing parts. So let's go ahead and look at a more complicated one. So we'll look at number 6. So number 6, I'm going to kind of look at this first angle here because I know here's the triangle, so I know those add up to 180. So angle 1 plus 61 plus 68 equals 180. Okay, so those two angles, 61 plus 68 is 129. And so whatever's left over out of 180 is going to be angle 1. So angle 1 equals 51. Okay, so that's 51. And then angle 2 and 3, well, look at what we have here. 61's here. Angle 2 and 61 are a vertical angle situation. So that's just 61. Okay. So in that case, I can use, well, 2 is 61. This is 90. Then we can go ahead and find the angle 3. So that's going to be angle 3 plus 90 plus 61 equals 180, and then find what's left. So that's 151, equals 180. And when I subtract 151, that's going to give me my answer. So angle 3 equals 29. There we are. Okay, so you can kind of use either way on that to get what the missing angle is. All right. So let's look at just one more here. Looking at one of these. Okay, so number 12. Basically the same situation, but you got some X's here. So you got a triangle. Those three angles have to add up to 180. So I've got 9x, 9x plus 3 plus 11x minus 21 plus 5x minus 2 equals 180. And now we solve. So combine like terms. I've got 20x plus 5 is 25x. And then 3 minus 4 is, that's a 4, right? No, that's 21. My handwriting's so bad. So 3 minus 21 is negative 18. Negative 18 minus 2 is negative 20 equals 180. So add 20, and I get 25x equals 200. Divide by 25, and we get our answer. X equals 8. So if that's 8, now we can find all of our angles by just plugging it in. Okay, so plug it into the first one. Plug in 8 for x. I get 9 times 8 plus 3. So 72 plus 3 is 75 for E. So angle E, 75. Same thing for D. So 5 times 8 minus 2. So that's 40 minus 2, which is 38 for D. So D, 38. And then the last one, 11 times 8 minus 21. That's 88 minus 21, which is 67. So 67 for F. Okay, so something I want you to try, and we'll talk about it tomorrow, is you're going to go ahead and try number 13 and 14. Okay, so if you need to pause it real quick to solve the missing parts, you can go ahead and pause it, write those down, whatever you need to do, and we'll talk about those tomorrow on Zoom, and then we'll have some kind of knowledge check. All right, email me or Zoom me if you have any questions, and I'll see you soon. Peace.